Today we're going to talk about roots and radicals. Students will find roots of real numbers and simplify expressions involving radicals. So for example number 1, we're going to simplify and we have the cube root of 125. Well, we can rewrite the cube root of 125 as the cube root of 5 to the third. And so if you have a cube root of something to the power of 3, they cancel out and you get 5. For part B, we can change the negative 243 to negative 3 to the power of 5. So the fifth root of negative 243 is negative 3. And then for part C, we can change the way this looks so that it's 0.3 or 0.3, 3/10, to the fourth power. Okay, so that's how you can simplify things that are perfect cube or perfect to the fifth power. No. So let's take a look at example number 2. Find the real roots of each equation. If there are none, say so. Remember, it says real roots. So we have x squared equals 0.49. Well, to get x by itself, we're going to take the square root of both sides. Now remember, anytime you take the square root of both sides, you need a plus and minus. Because the answer could be both positive or negative. Now remember, that's when it's a square. Okay? That's not true for cubes, but for squares. All right, and then the square root of 0.49 is 0.7. All right, now let's take a look at part B. 3x squared equals 432. Well, first we need to get the x squared by itself, so we're going to divide both sides by 3. Then our next step is to take the square root of both sides. Remember, whenever you do that, you need a plus or minus. So you end up with x equals plus or minus 12. Now let's take a look at part C. 5y squared plus 45 equals 0. First, we want to subtract the 45. Then we're going to divide by 5. And then finally, we'll take the square root. Don't forget your plus or minus. Now, here's the question. Can you find the square root of negative 9? Well, actually we can, but it's not real. And the problem originally said find the real roots of the equation. So for right now, we're just going to say this isn't real. And we'll come back to a problem like this later on in the semester. And now let's take a look at part D. 4z squared minus 24 equals 0. So first we're going to add the 24. Then we're going to divide by 4. So now we have z squared equals 6. So we need to take the square root of both sides. Remember the plus or minus. So z equals plus or minus the square root of 6. Now remember, 6 isn't a perfect square. It also doesn't simplify into a perfect square times something else. So we're just going to leave the answer like this in radical form. because that's exact form. We're not going to change it to a decimal. We want to leave it in radical form because radicals are exact. Now let's take a look at this little thing and let's talk about some terminology that we're going to use. So here we have the nth root of b. Okay? So b is what we call the radicand. That thing inside the radical is called the radicand. All right, and then this, that little symbol is called a radical. That symbol is called a radical. And then that number that's in that radical, and if there's not a number, it's assumed to be a 2, but that's called the index. And we usually say the nth root of b. So it could be the third root, the fourth root, fifth root, sixth root, cube root. We usually say the third root. So those are some terms that you might need to know throughout this unit. All right, so let's take a look at part A, for example 3. We have the fifth root of 64. Well, let's see. Can we break 64 down into something to the fifth power times something else? Well, 2 to the fifth is 32, and then times another 2 gives us 64. So we can take the fifth root of 2 and the fifth root of 2 to the fifth, and that's the same thing as the fifth root of 64 because 2 times 2 to the fifth is 64. Well, this one can't simplify, but this second part can simplify to just 2. So the fifth root of 64 can simplify to 2 times the fifth root of 2. Now let's take a look at part B. We have a square root of 18m to the third. So can we break this apart into a perfect square times something else? Well, we can break that up into 9m squared because 9m squared is a perfect square, and times 2m, okay? And then we can take the square root of each of those. Well, the square root of 9m squared is just 3m. And then the square root of 2m doesn't simplify, so we just leave that the way it is. And that's your answer. Now let's take a look at part C. We have the cube root of 81 over 8. All right, so we can break 81 up into 3 cubed times 3 over 2 cubed. And since it's a cube root, we can simplify this, and here your 3's will cancel, so you're left with a 3. You still have this 3 under the radical right here. And then the cube root of 2 cubed just leaves you with 2. So your answer is 3 cube root of 3 all over 2. Now let's take a look at D. Part D, we can't take a cube root of 5 or a cube root of 4, but if we look at the prime factorization, the 5 stays the same, but the 2 is raised to the second power. So is there a way we could change this without changing the value of the fraction to make this a 2 cubed so that we don't have a radical in the denominator? What could could we multiply this by to get 2 cubed? We could multiply by 2 underneath this radical, which means whatever we do to the bottom, we have to do to the top. And so we'll just kind of extend that radical. All right, so now we have the cube root of 10 over the cube root of 2 cubed, which the cubes are going to cancel. So our answer is the cube root of 10 over 2. Now, the reason this isn't simplified is because you have that radical in the denominator. So we need to figure out how to get rid of the denominator in the the radical in the denominator. So that's why we needed to multiply by the 2 over 2, so that way we could get rid of the radical in the denominator. All right, let's try some more. Example number 4. Now we're getting into multiplication of radicals. Okay? So now they're very similar to when you have multiplication with variables. We're going to multiply the coefficients first. So 5 times 3 is 15. Then we're going to multiply what's inside the radical. Now, you could do this one of a couple ways. You could break it down. And the 24 can become 8 and 3. I don't know how well you can see that. So let's try this again. All right, so we've got 5 times the 3. And we're going to break that 24 down into 8 and 3. Because then when we multiply, inside the radical, we have 8 times 8 times 3. So we have 2 of those 8s. So that's really the same thing as saying 8 squared. And what's the square root of 8 squared? 8. And then that square root of 3 stays the same. And then when you take 8 times 15, you get 120. There are other ways to solve the same problem, and we'll talk about those in class. But that's one way of looking at it. You could also have multiplied the 24 and the 8, and then tried to simplify it after that. All right, let's take a look at part B. We have 12 over the square root of 5a. Now remember, we can't have a radical in the denominator, so we have to get rid of it. Well, the easiest way to do that is, if this is a square root, just multiply it by itself, and then you have a perfect square. But remember, whatever you do to the bottom, you have to do to the top. Now, on the denominator, you have the square root of 5 squared times a squared, so the squares are going to cancel out with that square root. And that can't simplify any further.